What are common PyTorch loss functions? Imagine you're teaching a robot to recognize objects or predict house prices. How does the robot know if it's doing well or needs to improve? That's where loss functions come in. They act like a scorekeeper, telling the model how far off its predictions are from the real answers. In PyTorch, a popular machine learning framework, loss functions are essential tools that guide the training process. They help models learn by providing feedback after each guess. Different tasks need different loss functions. For predicting numbers like ages or temperatures, you might use regression loss functions. For classifying images or text into categories, classification loss functions are used. And for ranking or ordering tasks, ranking loss functions come into play. For regression tasks, the most common loss function is the mean squared error loss. It calculates the average of the squared differences between what the model predicts and the actual values. Larger errors are penalized more, which makes it sensitive to outliers. Another popular choice is the mean absolute error loss, which takes the average of the absolute differences. It is more forgiving of outliers and provides a different way to measure error. There is also the smooth L1 loss, sometimes called Huber loss. It combines the best of both worlds by being less sensitive to outliers than mean squared error but more stable than mean absolute error. It is often used in object detection tasks where some errors are more tolerable than others. When it comes to classification, the most widely used loss function is the cross-entropy loss. It measures how different the predicted probability distribution is from the true distribution, which is usually one-hot encoded. This loss is perfect for multi-class classification problems. For binary classification, binary cross-entropy loss is used. PyTorch provides a special version called BCE with Logit's loss that combines the sigmoid activation with the loss calculation for better numerical stability. The negative log likelihood loss is another option, especially when models output log probabilities. It is often used with a log softmax layer. Hinge loss is also used in support vector machines, encouraging the model to correctly classify with a margin of separation. Ranking loss functions focus on the order of predictions rather than exact values. Margin ranking loss helps train models to rank pairs of inputs, pushing preferred items higher. Triplet margin loss is popular in face verification tasks, where the goal is to bring similar items closer and push dissimilar ones apart. Kullback-Leibler divergence measures how one probability distribution diverges from a reference distribution, which is useful in tasks like knowledge transfer between models. Choosing the right loss function depends on what you're trying to do. For example, if your data is noisy, mean absolute error might be better. If you're classifying multiple categories, cross-entropy loss is usually the way to go. Understanding these loss functions is key in AI development because they tell models how well they are learning and what to improve. Whether you're building a text generator like ChatGPT or an image creator like DALL-E, loss functions help guide the training process. They also raise ethical considerations, because biased data can lead to biased models if the loss functions are not carefully managed. PyTorch offers a rich set of built-in loss functions that support many different tasks. This flexibility makes it easier for developers to build models that generate accurate predictions, classify images correctly, or rank items effectively. Knowing which loss function to use is a fundamental step in creating successful AI systems.